Good morning. Today I am going to the topic design of experiments. Experiment. What is an experiment? A collection of data or measurements of some features of an object. Experiment means a collection of data or measurements of some features of an object. Treatment. A various objects of comparison in a comparative experiment are called treatment. A various objects of comparison in comparative experiment are called treatments. Experimental unit. The smallest division of the experimental of material to which we apply the treatments. Next, blocks. Whole experiment units are divided into subgroups. Whole experiment units are divided into subgroups are called blocks. Experimental error. It is the error occurred due to random cases or chance cases or non-assignment factors which are beyond control. The basic principles of experimental design is randomization, replication and local control. Basic design of experiments are three types are there. The first one is completely randomized design or one-way classification. Second one is the randomized block design or two-way classification. Third one is Latin square design. Today going to the topic, first one is the completely randomized design, one-way classification. The step one, write H0 and H1. H0 is the there is no significant difference between column and errors. H1 is alternative hypothesis, H0 is null hypothesis. H1 is alternative hypothesis is written as there is a significant difference between column and errors. Step 2, find the value of n. N means the number of given observation. Find t. T will be the total number of observation. Find the correction factor. TF is t square by n. Sum of squares of treatment SST formulas are there given. Summation x1 square plus summation x2 square plus summation x3 square minus correction factor is SST. SSC means summation x1 the whole square by c1 plus summation x2 the whole square by c2 plus summation x3 the whole square by c3 plus etc minus correction factor. Next, finally, the sum of squares of errors is SSE equal to SST minus SSC. Next one is the ANOVA table. The square source of variation between columns and errors. Degrees of freedom C minus 1 and N minus C. Sum of square SSC and SSE. Mean sum of square MSC equal to SSC by C minus 1. Means sum of errors SSE by N minus C. Variance ratio MSE by MSE. MSC by MSE. Next, MSE equal to SSE by N minus C. Variance ratio MSC, MSE, MSE by MSC and table value is F alpha. Finally, accept or reject the hypothesis. Decide. The one sum is we go to the one problem. A random sample is selected from each of these makes of ropes and their breaking strength are measured with the following results. Test whether the breaking strength of the ropes differ significantly. First one, second row and third row values are given. Go to the solution. Step 1, H0, there is no significant difference between column and errors, the null hypothesis. Next, alternative hypothesis, H1, there is a significant difference between the column and the error. Step 2, N be the number of observations is 18, number of values. T, the total sum of values, 1576. Correction factor is T square by N, 1,30,987.55. Next, SST is formula is there. The table values are x1, x2, x3 and also x1 square, x2 square, and x is, so we have to find, and the summation x1 square, 2 square values are finding this one. SST is the values are given. SSC, the formula, apply the formula and get the value is 5838.44, and SSE is 1126. SST minus SSC, apply the formula and substituting the values are in, you have already seen the ANOVA table. Substitute the value and compare the calculation value and the table value. We reject the hypothesis. The given is calculation value is greater than the table value, also we reject the hypothesis. There is a significant difference between column and errors. That's all. Thank you.